one of the things that you had worked on in your problem set was that the derivative does not exist at a corner or at an endpoint. I'm going to show you a little picture of how and why that's going to work out, and really what's going on here. First off, remember that the derivative comes from the difference quotient, and so I've got it written over here. The difference quotient, f prime of x, is equal to that limit as h approaches 0, f of x plus h minus f of x divided by h. That was the slope formula, the slope between 2 points. In our example here, I made a graph that had a hard corner at C. Now this point right here is actually going to be C comma f of C. And we're going to go ahead and find out what happens to the slope at that point C. And so I replaced my difference quotient here with C. So my derivative at C is the limit as h approaches 0 of f of C plus h minus f of C divided by h. So if I pick any point, I'm going to bring in my green point here. If I pick any point for this graph, we're going to be able to go h units to the side, find out its new x value and its new y value, and find the slope between those 2 points. And as that happens, you'll notice something quickly from the right hand side. Now, obviously the graph that I drew was a straight line, and so as that point gets closer and closer and closer to the value of C, the h is approaching 0. Now my h values are all positive values in this case, and I'm getting closer and closer to a specific value. Now, because that's a linear graph, that slope is staying the same the entire time, and it appears, let me move this out of the way, it appears that slope is, let's see, we've got we'll say it's a 1, 2, 3, 4, 5, 6, 7, and up 3. So it looks like we've got a slope of 3/7 as that value. But on the other case, my h is approaching 0. It doesn't really say which direction I'm approaching it from. What if I'm approaching it from the left-hand side? What if my h values are negative? And in that case, this point will be getting closer and closer and closer and closer and closer. So close it's going to actually touch, and as I gather all of those values of the slope, I notice that its slope is different. It looks like here we've got a fall of 1 and a run of 1, 2, 3, 4. It looks like this has a slope of -1/4. So when I'm looking at this limit, I end up having 2 values from 2 different sides. From the right-hand side, the limit has a value of 3/7. From the left, that value has that slope. All those slopes are approaching 1/4. Well, you can't be approaching one value when it's 2 distinct different pieces. Those are not the same. I can't approach 2 different values and get one final value. So in this case, the limit does not exist. Now, if I'm going to say that the limit doesn't exist, the derivative is that limit, so that means that the derivative does not exist at C. And that's going to happen for any graph that we see that comes to a hard corner. If we really want to look into it, we can see that the slopes from one side do not approach the same values as the slopes from the other side. And so since they don't approach the same value, I can't say that the limit exists at that point. Now, I mentioned that corners. Let me get rid of this here. So let's say I just had that one side of the graph, and my C is now the endpoint of that graph. When it tells me to solve the limit, I need to approach 0. I can approach 0 from that right-hand, the h can approach 0 if my h values are positive, but there's no way that I can approach C when I have negative x values. As h approaches 0 means that I'm going to come at 0 from both sides, positive values and negative values. There are no negative values on the other side here, so that there's no other side of the limit. Since this is calling for both sides, I need to come at it from both sides. It doesn't exist. Therefore, my limit isn't going to exist at an endpoint, and my derivative won't exist at an endpoint. There are going to be times when the limit can exist at an endpoint, but we're going to need to talk about one-sided limits, directional limits. But for now, for what we saw in this last unit, the derivative won't exist at a cusp, at a hard corner, or at an endpoint.